Guys, we are in the chapter amyloidosis. So here we are going to now talk about the physical and chemical nature of amyloid. Okay. Now, what we are trying to tell you here is physically all amyloid are same, but chemically they'll be different. Okay. Let me show you some diagram. Here in the circle you can see that the amyloid is mainly made up of fibrils. Okay, these are fibrils. These lines you see, they are fibrils. 95% will be fibrils, and these dots you see, these dots, these are all the non-fibrillar component. Okay, mainly they'll be the P component. They look like donuts actually. So this is the diagram you can draw to get marks if they ask for amyloid structure. Under the electron microscope, amyloids look like this. They'll have fibrillar components 95% and non-fibrillar components will be around 5%. And in that non-fibrillar component, P component will be maximum. Now these fibrillar components, when you zoom, they'll actually be like this. They'll be double helix. Okay. And each of these helix will actually finally be a beta pleated sheet. Beta pleated sheet is what makes the amyloid insoluble. Can you see? These are actually beta pleated sheets. Fine. If you can practice this beta pleated sheet, no, you will get nice marks, I'm telling you. So you can just draw something like this, right? And get nice marks. Please practice this diagram. Whenever you write diagrams, you will get more marks. I'm just trying to tell you, draw something like this to show the amyloid structure. And don't forget this one also. Draw a nice circle and put some lines inside it and put one dot. Here and there one dot. That much will fetch you so many marks, right? Very good. Okay. So this is the amyloid structure. Fibrillar will be 95% and non-fibril will be 5%. Let's go into the details. Let's dive in. Just creating something for you. There will be fibrillar components 95%. Then you have the non-fibrillar 5%. Fine. And under fibrillar you have some things which are very common, and then you have others which I will give you details on. Non-fibrillar you will have, as I have already told you, P component will be maximum. This is that circle donut type, right? I told you, donut like. Fine. Are you awake? Can we continue? Good. Guys, so I told you fibril protein you have A, L and AA. Okay, main we have AL and AA. First, let me tell you about fibril proteins. So basically you have seen the diagram, right? In the circle there are a lot of lines. So these are meshwork. Please focus here. Meshwork of fibril proteins are there. These are delicate, randomly arranged, non-branching. Have you seen them branching? Not at all, right? So they are non-branching and they are wound. These fibrils are wound on each other. That helix I told you. And they are in beta pleated sheet configuration at specific points. Regularly there will be binding sites for the Congo red dye. That is what I have showed you till now. Please look at the diagram again. As you can see here, these are the fibrils arranged like I told you, like a meshwork. They are delicate, they are randomly arranged and they are non-branching, correct? And these fibrils are arranged as they are wound up on each other like a helix, and in the beta pleated sheet you can see for Congo red to attach, the dye to attach, there are specific places, intervals, regular intervals are there where the Congo red dye can attach. That is why amyloid is also called as beta fibrillosis. Amyloid is also called as what? Beta fibrillosis. Now let's move on to the types of protein that you can see here. AL protein, that is the amyloid light chain protein, and the AA protein, that's the amyloid associated protein. What and all can you see? Amyloid, what is AL? Amyloid light chain. Wherever there's A, it's amyloid, I told you. Amyloid light chain, and AA is amyloid associated protein. And there are other proteins. So the other proteins for you will be transthyretin. Okay, transthyretin. This transthyretin is also called as TTR. Okay, the other one is, it is A beta 2 microglobulin. Say A
A beta
2 microglobulin.
Microglobulin.
Very good. Then you have amyloid beta peptide. Say amyloid beta peptide.
Amyloid peptide.
Yeah, amyloid beta peptide. Then you have endocrine amyloid. Endocrine amyloid. Endocrine amyloid. Endocrine amyloid. Then you have amyloid of prion protein. Amyloid of prion protein. Prion protein. So these were the fibrillar components of amyloid. Amyloid fibrillar components. That is why amyloid is also called as beta fibrillosis. Correct? Amyloid is also called as beta fibrillosis.
Amyloid.
Now tell me which are the fibrillar components? AA, transthyretin, A beta 2, microglobulin, amyloid beta peptide, endocrine amyloid. Say properly. Amyloid of prion protein. Okay. Now let us look at the non-fibrillar components. See, non-fibrillar components, mainly you have to look at this AP component, because this AP component helps in staining. So you have the AP component, non-fibrillar. Then you have the apolipoprotein E, apo E also you can say. Sulfated glycose aminoglycans, GAG, sulfated GAGs or sulfated glycose aminoglycans. Similarly, in this also you have an others group, under which you have alpha-1 anti-chymotrypsin, protein X, components of complement, proteases, membrane constituents. So much to remember, right? So let me tell you what is important here. AP component is important because it is the one that's going to help in staining. So non-fibrillar mainly composes of the P component or the AP component. Okay. So is this much clear? So this is a very gist of the composition of amyloid. You will have to dive deep into these to understand more. Just to close in, I want to say amyloid light chain, right, and amyloid associated protein, correct, AA.